In the modernization process of China's Air Force, why is the mixed use of J-16 and J-11BG regarded as a strategic turning point? This is not only about the synergistic operation capability of the two fighters, but also reflects how China's aviation industry is moving from imitation to independent innovation, and finally realizing overtaking in the technological wave of 4.5-generation fighters. The evolutionary history of the Sidewinder family, spanning 3 decades, is not only a history of equipment upgrading, but also a microcosm of the national strategic will. The story began in the early 1990s, when China imported the first batch of Su-27 fighters from Russia. This Soviet-designed heavy 4th-generation aircraft had allowed the PLA Air Force to touch the threshold of modern air combat for the first time. However, the import-dependent Su-27 is equipped with only Ir-27 semi-active medium-range rounds, and the radar system is jokingly called the inverted card magic weapon. Its bulky N001 radar weighs nearly 1 ton, and its detection range and anti-jamming capability are far inferior to that of Western equipment at the same time. This constrained predicament, forcing China to open the road of localization. 1998, the first domestically assembled J-11 off the production line, although the initial realization of the local production, but its avionics system and the Russian version of the same. The cockpit densely packed mechanical instrumentation as if the pilots back to the era of the watch store. The original plan was to produce 200 J-11s, but only 100 or so were completed before coming to a screeching halt, a setback that has given rise to the awakening of China's aviation industry. The J-11B, which was introduced in 2007, marked a real step into the independent innovation stage of the Sidewinder family. The application of the domestically produced 1,493 flat-panel slit radar, composite wings and digital flight control system increased its detection range to 130 kilometers and made it compatible with the Thunderbolt 12 medium-range bombs for the first time. However, with J-16, J-20 and other 4.5 and 5th-generation aircraft entering service after 2016, the shortcomings of the J-11B are once again exposed. The mechanically scanned radar can't match the Thunderbolt 15 over-the-horizon missiles, and the avionics architecture is difficult to integrate into a new generation of combat systems. At this time, China is facing a choice with strategic wisdom. Instead of retiring more than 300 J-11Bs that have not yet reached the end of their lives, it would be better to give them a new life through midterm upgrades. Thus, the J-11BG was born. This transformation is called surgical upgrade. The active phased array radar hidden under the gray-white radome, with the same source as J-16, the detection range jumped to more than 200 kilometers, and it can track 20 targets and attack 6 of them at the same time. The traditional instrumentation in the cockpit is replaced by a large area of liquid crystal screen, and with a new type of helmet sight, the pilot's situational awareness ability is improved. In addition, the traditional cockpit instrumentation has been replaced by a large LCD screen, and with the new helmet sights, the pilot's situational awareness has been doubled. The turbofan 10C engine has replaced the Russian-made L-31F, increasing the thrust by 15% while extending the service life to 4,000 hours. What's more, the upgraded J-11BG is fully compatible with the Thunderbolt 15 TENS missile system, and its over-the-horizon air combat capability has surpassed that of the Russian Su-35, which is equipped with a thrust vectoring engine, but is limited by a passive phased array radar, an outdated electronic impedance system, making it difficult to defeat China's upgraded version of the Sidewinder in systematic combat. However, the J-11BG is not perfect. Its structural strength is still limited by the original design of the Su-27, and the lack of composite materials makes it less versatile than the J-16. For example, the Su-27 series can only carry 6 tons of load due to its weak wing root structure, while the J-16 can carry more than 8 tons of ammunition by redesigning the wing box and thickening the skin. This difference determines that the J-11BG is more oriented to air superiority missions than the J-16's all-round bomb truck. When these white-headed J-11S and J-16S appear in the same unit, their significance goes far beyond simple equipment coexistence. The J-16, as China's strongest active 4.5-generation multi-purpose fighter, is not only equipped with more advanced electronic warfare pods, but can also mount 8 tons of ammunition to carry out anti-ship and ground precision strike missions. But its unit cost is as high as $80 million, and its production rate has slowed down due to the 5th-generation aircraft prioritization strategy. In contrast, the J-11BG's upgrade cost is only 1/3 of the new aircraft's cost, but it can share battlefield information with the J-16 through the data link, forming a tactical synergy of high and low. The former builds an air defense barrier in front of it with its upgraded radar, while the latter uses its ammunition capacity and range to build an air defense barrier. The former builds an air defense barrier in front with its upgraded radar, while the latter utilizes its ammunition capacity and range to carry out deep strikes. This combination not only alleviates the pressure of the shortage of 5th-generation aircraft, but also reduces logistical complexity through generalized avionics, and maximizes the residual value of the 300-old equipment. From a real-world perspective, the complementary nature of the two is especially prominent in the Taiwan Strait simulation and projection. The J-11BG can carry Thunderbolt 15 missiles to blockade the airspace of the first island chain and suppress the long-range strike capability of opponents such as the F-15J, while the J-16 can mount Hawk 12 anti-ship missiles to carry out saturation attacks on maritime targets. This division of labor has already taken shape in the 2024 China-Thailand joint military exercise. The J-11BG, with its upgraded radar, repeatedly shot down Thai Eagle Lion fighters in over-the-horizon confrontations, while the J-16 demonstrated the effectiveness of precision strikes against ground targets. Compared with similar international upgrade programs, the cost-effectiveness of the J-11BG is particularly outstanding. While it costs the $130 million per aircraft to upgrade F-15C to F-15X, the J-11BG can achieve 80% of the 4th-and-a-half-generation combat capability at a cost of only $20 million per aircraft. The modernization and upgrade of Japan's F-15J is slow and costly due to its dependence on U.S. technology, while the improvement of South Korea's F-15K is limited by the shortcomings of the local industrial chain, which has so far failed to break through the bottleneck of radar and engine. On the contrary, relying on the complete aviation industry system, the radar, avionics and engine of J-11BG are all localized, and this autonomous and controllable upgrade mode has become a strategic advantage that is difficult to be copied by small and medium-sized countries. However, the limitations of J-11BG cannot be ignored. Its airframe life has been depleted by more than half due to high-intensity training, and some of the early batches even face the risk of structural fatigue. Although the reliability of the turbofan 10C engine has improved significantly, there is still a 5% thrust difference compared to the turbofan 10B of the J-16, resulting in a slightly inferior supersonic cruise capability. In addition, the lack of stealth design puts it at a disadvantage against the F-35, which further emphasizes the need for China to accelerate the mass production of the J-20. The J-11BG's hybridization practice has provided the Chinese Air Force with a unique equipment development path, injecting 4.5 generations of combat power into a 4th-generation platform through systematic upgrades rather than a full replacement. This strategy not only avoids the Russian Su-57's lack of production capacity, but also circumvents the waste of resources caused by the premature retirement of the US F-22. In the future, with the integration of artificial intelligence-assisted decision-making systems and loyal wingman technology, the J-11BG may become a key node in manned-unmanned coordinated operations, with its radar and data link capabilities commanding unmanned swarms to perform forward reconnaissance and saturation attacks. Looking back at the evolutionary trajectory of the flanker family in China, from the toddler of the J-11A to the independent walk of the J-11B, and then to the wing-to-wing flight of the J-11BG and the J-16, each leap is closely related to the national strategic needs. When the US is busy upgrading the F-15C to the Golden Eagle, China has chosen a more cost-effective path. This kind of pragmatic innovation not only makes the former Sidewinder transformed, but also reflects the role of China's Air Force from catching up to the role of the rule-maker metamorphosis. In the future, as the J-11BG fleet fully forms combat capability, this old bottle with new wine Air Force will write a new air control legend in the sky of the East China Sea and South China Sea.